Welcome back. Let's talk about space complexity. What if I have a function that has the name of Boo, and all it does is it takes an input, and within this input, it's going to simply have a loop that we've seen before. And this loop, let's make sure that I do this properly. Let's say that n.length, and we'll say I++. And this function is a really useless function that just simply logs out console.log boo. Scary function. So now in here, if we just run the function and just give it an input of, let's say, 1, 2, 3, 4, 5, and run it, well, we have Boo running 5 times. And we know that the space complexity of this function, or time complexity of this function, is O(n). But when it comes to space complexity, let's think about this. What is the space complexity of this? Now, try to guess before I go into the topic. The one gotcha when it comes to space complexity is that when we talk about space complexity, we're talking about additional space. So we don't include space taken up by the inputs. So we don't really care how big the input is. I mean, we do care, but when it comes to this function, we don't really have a control over what sort of input it receives. We only have control of what happens inside of this function. So within this function, are we adding any space? Well, not really. The only thing we're really doing is we're creating this let I equals 0 variable. And that's it. Other than that, we're not really adding any more memory. So this function has a space complexity of O(1). Nice and simple. But what if we have a different function? What if we have something like this? This time we'll have a function that says array of, I'm going to give it another terrible name, high and times. God, that's a terrible name. But let's say that this function takes, again, an input. And within here, we're going to create a new variable. We're going to say let high array is going to equal an empty array. And within here, we're going to have a loop. I'm just going to copy this for now so I don't have to bore you with my typing. And in here, I'm going to simply say high array in the index. So as we're looping, we're going to fill it up with high. And we're going to return this array, high array. All we're doing is we're creating a new array. And for the number of items in our input, we're going to just fill up high array with repeatedly high string. So if I do this again and I say array of high and times, and I give it, let's say we'll give it, and you know what? Instead of length here, let's just leave it as a number. So I'm going to say n, and I'll say 6 times. So if I run this code, we see that even though we have the boo over here from the beginning, the other function, array of high and times, returns us a new array with 6 items, and each item just simply says high. What is the space complexity of this? Well, this should give you a hint. Remember our cheat sheet. Variables, data structures, function calls, allocations, those things take space. And in our case, we created variables in our loop, variable I equals 0, But we've also created data structures, right? We created a new array. So now if we go back, we see that in here, we've created a new array and we fill this array with n loops. And again, because of our rules when it comes to big O, we ignore the constant time, let I equal 0 space, and instead this becomes O of n, because we're creating a new data structure and adding memory, so each item is an additional memory space on our computers n times. And you know what? That's pretty much it when it comes to space complexity. I think you're getting the idea, and we'll get a little bit more into it when we talk about recursion. But when it comes to space complexity, you're either adding additional memory that you need to use, and that's sometimes a big concern, and sometimes there isn't. And something that comes up a lot in interviews, and something that we'll talk about in the next section. That is, sometimes there's a trade-off between saving time and saving space. So you have to decide which one you're optimizing for. Let's get into some fun examples based on what we've just learned in the next video. See you in that one. Bye-bye.